Okay, good morning, everybody. Thank you very much for joining me in this talk today about trying to break out of the typical scenario of building business applications in .NET MAUI and focusing on having a bit more fun. In terms of the format, I've tried to fill as much of this slot as possible, so I'll try and keep questions towards the end if we can, but I will try to make sure there is time. Although on the topic of saying that you might not have time for questions, I'd like to start by asking yourselves some questions. Who here has had a great idea for a game format? Go ahead. Oh. How about now? Is this any better? More? Is this better? A bit better? Should I keep talking until we get to a better level? A bit more? Keep going? How about now? Is this better? Yep, okay, let me start again. Hello everyone, thank you very much for joining me. I'd like to try and talk to you today about breaking out of maybe building a typical business application that .NET MAUI is typically touted for and focusing on having a bit more fun. I'd like to start by asking a couple of questions of yourselves. So who here has had a great game idea? No? Fewer than I was expecting. Who here has turned that idea into an actual concept that you could try and prove? Thank you, David. And finally, who here has started on that great idea only to be distracted by something completely nonsensical and disappearing down a rabbit hole into building something you didn't need? I certainly have my hand up for these questions. David did as well, but that's precisely what today's talk is all about. Let me just quickly get the introductions out of the way. My name is Shaun Lawrence. I'm an independent software engineer, and I typically work on functional business applications. So there isn't a lot of freedom to be able to flex my creative side, but hopefully today we can break out of that. I was very lucky to be awarded the Microsoft MVP this year, last year now, which relates to the open source work that I typically do on .NET MAUI Community Toolkit and the Xamarin Community Toolkit. And a little bit of what we're talking about today is something called the Orbit game engine, which is taking .NET MAUI and then being able to build 2D games with it. And then finally, it does claim that I'm an author, but it's currently in production. So if anyone is interested in learning about how to use .NET MAUI, come about May time, then I would thoroughly recommend a book called Introducing .NET MAUI. So what are we going to cover today? Hopefully by the end of the session, you'll learn about two of my great passions, what is .NET MAUI, gaming in general, and then how we can then combine them together into something that can be fun in terms of the development process as well as actually the output. A lot of the work that I've been doing is probably, I don't know if this is quoting David, more about the journey rather than the destination, because as developers, that's what we enjoy. So we're going to look at what we can achieve with .NET MAUI out of the box, and then look at how we can then bend it to do what was probably considered a typical game. So we're looking at a game engine and how we would build that into .NET MAUI. And then finally, there'll be some tips and tricks to help you avoid any pitfalls that I have experienced over the past months. So a very brief introduction as to what .NET MAUI is. If anyone didn't catch Gerald's talk yesterday, he gave a much more in-depth detail, and that will be available, I think, to catch up on. But like I said, this is rather brief. .NET MAUI is a cross-platform framework to allow you to build modern applications. And that gives support for things like mobile idiom in terms of Android and iOS. We've then got desktop support in Mac OS and Windows. And then through third-party support via Samsung, we can run on smart TVs and smart fridges via the Tizen platform. And actually, a colleague of mine yesterday, Jay, sent a photo of one of the sample games from this repository running on a Samsung fridge, which is quite impressive. On to a bit more. .NET MAUI is the evolution of Xamarin Forms. We ended with Xamarin Forms 5. We had .NET MAUI 6, and now we're on to 7. It is now versioned and released alongside .NET. So we get a major version every year with long-term support every other year. The evolution does bring a lot of much-needed benefits. I don't know if many people here have dealt with Xamarin Forms in the past, but there were lots of things that left it lagging behind. But now being part of .NET officially, we get much better support for things like modern languages, so we can actually deal with the latest C# features. We're not lagging behind on that. And then we've also got far superior built-in support for things like dependency injection. So If anyone's built an ASP.NET Core application, you'll be familiar with the app builder pattern. You get exactly the same thing in MAUI. I think a belief I have is that it then allows us to transition between .NET code bases far simpler because we're all looking at the same kind of pattern. We've covered briefly what .NET MAUI is, so now let's look at what a game is. According to Wikipedia, it's a structured form of play. So this could be anything from a card game, a piece of Sudoku on a piece of paper, Exploding Kittens, which is a family favorite, or even then we can move across to something like a console game or even virtual reality games. So it can be anything that ultimately becomes fun. Sadly, I hoped to get a great quote out of my children for a game, but they've now turned it into a game of just hitting me with dictionary definitions. So now we've covered what .NET MAUI is very briefly and what a game is. Now we can start to look at what we can do when we combine the two together. There are actually a lot of games that we can build out of the box. So if we use a typical business application architecture like MVVM, there's a number of games that we can build, and here are two examples of doing that. Like I say, this is actually built with Xamarin Forms, but it is slowly being migrated across to .NET MAUI. And a lot of these functionalities are using either built-in support or third-party packages. So we've got things like, there's an animation class that allows you to animate your UI, make it feel alive to the users. There's things like Lottie, which I don't know if anyone's familiar with Lottie, but that's a really quite fantastic piece of technology that I've fairly recently discovered. It allows you to render any form of animation in an application, and it is rendered in the application, therefore you get scalability. It's not like embedding an animated GIF in there and you have to deal with sizing issues and actually bloat, because it boils down to a little JSON file, so actually it performs pretty well as well. The word search app on the right is closed source, which makes it difficult to then show off the functionality. So as part of the recent work I've been doing is taking the key concepts of this one and then being able to show you how you can achieve the same things, but in an open source project. So like I say, is we've got the ability to animate things. There's either inbuilt functionality within .NET MAUI where you can animate the scale just in a single method call, or you've got the ability to dive deeper in terms of building an animation programmatically. It becomes a little bit more in depth, but you can really get some quite fancy effects. And then finally, the one that I really quite like is the star effect that you see when the tiles match. And that's it's not something that ships with .NET MAUI. It's actually going down to the platform-specific layer where we can then implement a particle system. And I think one of the big selling points, while .NET MAUI is supposed to do a lot for you, you've still got the ability to get down to the layer itself. So on iOS, for example, we're dealing with a core animation layer, and we're generating a CA emitter, and then we're just firing particles off when we're calling it from the shared code base as well. So you can write your platform-specific code and then encapsulate it enough to be able to then interact with it directly from the shared code. There is a blog post here that shows you how to do this, takes you through each of the steps. I'm not going to focus too much on this today because actually there's hopefully some more fun things that we can start to look at. But I would like to point out that I wouldn't worry about keeping up with the links. There's a QR code at the end that will take you to a post that covers all of the useful links from today's talk. So we have looked at some of the types of games that we can start to build out of the box. So we're using things that come with .NET MAUI. But there are quite often scenarios when this approach is not enough. When we start to imagine games with multiple objects or characters that then each have their own states, things can become complicated very quickly. I couldn't quite decide whether this image accurately represents that previous statement or whether it's actually just my mental state after being on this journey. So what we would need to do then, when we get to this level, or to avoid this level of complexity, we're going to start to look at what's considered a typical game, and that is the primary focus of the talk today. But before we dig into the how and the why, I'd first like to show you an example of the game that had inspired this engine, and then we can look at how we can go ahead about building that. So, the great game idea that I came up with was a little bit of a twist on asteroids. We've got a planetary defense where you've got a ship on the right-hand side and you're controlling it in a very limited manner. You're orbiting a planet, and the idea is you can either speed up or slow down. And you've got a battery that will deplete when you use your thrusters, and therefore the aim is to control it well enough that you can then actually destroy the asteroids that are coming in to attack the planet. So if we watch it in action, we've got the ship. We've also, if you notice, there is a shadow on the right-hand side, so the aim is that if you're not within view of the sun, then you can't regenerate your power either, so it's trying to add a little extra levels of complexity. And eventually you'll see that the asteroids will collide with the planet. They don't collide with the ship yet. That is something that I'm currently working on. And ultimately you'll get into the level of it becoming too complex and you're running out of lives. It's an interesting one. I've gone on this journey, and I suspect actually the more fun has actually been in the building of the game rather than the game itself. But it's been able to kind of expose what .NET MAUI has to offer and what can potentially be achieved with the technology. The only other things I'd like to show quickly, just based on some extra slides that we're going to cover, we can start to be able to add in extra little bits of information. I mean, we can draw whatever we like on the canvas. It's really quite powerful. So when you realise your high school maths is not quite up to scratch, you can actually start to see why the objects are not going where they're intended. It did actually create quite a nice effect at first, whereas randomness in terms of where the asteroids were heading, but they weren't where they're supposed to be going. And then the other thing to note, we are going to have a bit more of a talk on accessibility as we progress, but the thing to consider when we're doing this is how we want to allow the users to actually drive the input. So at the moment, you click on the right-hand side or touch on the right-hand side and it'll speed the ship up. I can show you that. So I click, it speeds up, I click, it slows down. Then the other thing to consider is maybe you actually want to provide some visual buttons for people to click on, so it's a bit more obvious and inclusive. Okay, we'll leave that there for now. Okay. So on the previous slide and during that talk, I did refer to the term typical game, so I'd just like to take a step back and explain a little bit about what I mean by that. These are games that are typically built with game engines, and they involve a rather different way of working. So you could consider this probably the first real conceptual difference between a business application and a game, where what happens is, a business application will typically sit there idle waiting for user input, whereas a game loop, it'll be constantly looping, making sure that things need to be actioned are being actioned. It should feel fairly familiar if anyone's worked with a real-time based system. So some PLC programming or things like that, where, again, it's a looping approach and you're given an allocated set of time. If you exceed that, then you're put on the naughty step, you remove, because there's so many components that need to have time allocation. And we can see here in terms of the loop, what actually we'll end up doing is if we look at the right-hand side, the first step is we'll process user input, make sure we're not blocking. Then the aim is to update some state, and then eventually we'll turn that state into something that's rendered on the screen. So we've got the two separate states there that are really quite important, and we'll get into the detail of those. And then finally we wait, so then actually we can get to the point of providing a smooth frame rate. So we delay typically 16 milliseconds in order to provide 62.5 frames per second. And then there are techniques. So actually we could say, well, if we know that the right-hand side took 6 milliseconds to execute, then actually we'll deduct that from the wait. So then actually we try to provide as smooth a frame rate as possible. As I mentioned, it's key to try and not block as much as possible, because we have a limited amount of time to execute. So ultimately, if you're going to take longer than this, you end up going to introduce lag, and then ultimately the application is going to die and users are going to have a horrible experience. So now if we look at how this fits into .NET MAUI, some people have asked me why. Why did I try to do this? There are many answers. I'm not sure if I can decide any are good enough, but I guess the key takeaways are, in part of building the word search app, I was introduced to Skier, and I actually became quite impressed by what that did. So then when we then migrated over to looking at .NET MAUI, they'd actually introduced their own API, which is the .NET MAUI graphics API. What we then did was look at, I guess, just trying to find out what's possible. I was pleasantly surprised. I guess one slightly contradictory statement that I've come up with is I wanted to push myself outside of the comfort zone while actually still kind of keeping myself as comfortable as possible, staying in some level of comfort, and that comes in the fact that I'm familiar and comfortable with C# and .NET MAUI. I'm not familiar with the other parts, but that's the bit that I wanted to flex and try and investigate what's possible. Obviously, there are many other frameworks like Unity or Unreal Engine that will do far more than this. But the other key thing that I wanted to try and focus on is .NET MAUI is a UI framework anyway, so there's lots of functionality that it already provides that you don't need to implement and should feel fairly familiar when you're building an application. So the hope is that it might be an easier transition in from building this business application to just flexing that creative side of having a bit of fun. And then finally, the journey of building that demo application that we saw actually kind of identified some things that could quite easily be reused in terms of building my next great idea. So the plan has been to build on top of .NET MAUI graphics APIs. And for those not familiar with that, it's a surface that allows you to render, I say, pixel-perfect graphics on any platform supported by .NET MAUI. We can consider that an abstraction layer itself, just like .NET MAUI, in the fact that you interact with its API and it has its own platform-specific implementation. So being able to draw on iOS and all of that is covered for you. And that, to note, is, as I said, during my investigation on the word search, I'd come to the assumption that .NET MAUI graphics was built on top of Skiish, which it is not. It is entirely possible to swap it out. So they've built that abstraction layer in that you can put Skier under the hood if you don't want the MAUI layer. But obviously you're going to end up with a bigger binary because you're shipping more DLLs. And I personally haven't come up with a technical reason to do that, other than some unit testing side of things that we're going to look at later on. So I mentioned that .NET MAUI provides us with the two key components. We've got the graphics view, which comes from the .NET MAUI graphics API, a surface that lets you draw on things. That's relatively straightforward. And then we've got the dispatcher, so which allows us to schedule an action that will be performed after a time delay. And therefore, that's our wait loop. So we can see how that fits into this loop. The processing of the user input is a tricky situation because if we imagine we've got desktop devices, we've got mobile devices, we've got fridges. I don't even know how you're going to interact with a fridge. You could have Bluetooth controllers connected, any number of different control schemes. You might use the accelerometer on a phone as your input. There's no inbuilt way of just doing it all for you, or no easy way to abstract that away. So at the moment, user input in terms of trying to build a game with this engine, it would be entirely on your own. In terms of touch support, it's really quite impressive. You've got an extensive number of events that you can subscribe to from the graphics view, which is entirely available via the engine because it inherits from this. So everything that comes with .NET MAUI graphics comes with the engine, in the other hope that if new functionality comes out, you can just use it. You don't have to wait for a new release. And then because, like I said previously, MAUI is a graphics, a UI framework as it is, so it provides you with no end of ways to be able to build a UI and deal with that user interaction. So you can do it that way. The next step in our loop approach is to update the scene. So we simply update that and we tell it how long has passed since we last called you. And therefore that means that if you're dealing with movement information, you can actually use that as a ratio to calculate a smooth movement and things like that, all relative to when you were last called. And then the final step on the right-hand side we call render, which means we convert the state that was modified in the update method into something that's rendered on the screen. And in terms of the implementation detail of what I've been looking at is we just have to invalidate the graphics view, and that just tells it you need to go and redraw yourself. And then the final point in our loop is the wait, and that's just a case of scheduling something to be done after a period of time. So that's just calling back to the same method. The code you can't see here because it wouldn't fit on the screen is the calculations to work out how long it's taken in order to get you to the next step. We've covered a little bit on a little brief detail as to what got me to the engine, and then I'd like to show you actually how you can use it, because I'm hoping that it will provide you with a platform to actually go and create these ideas. I do believe the README on the repository provides a decent overview of how to use it. But, of course, if there's some things that aren't obvious, then please do feel free to reach out or raise an issue or a PR or anything like that to correct things. But much like most bootstrapping options now, with at least with .NET MAUI and other things like ASP.NET Core apps, we just have to call there's a use orbit engine extension method that will then register all the bits with dependency injection ready for you to use all of that goodness. In order to render something on the screen, we have to add in what's called a game scene view, and this will then actually provide the surface that you can draw onto. And it can function like any control in .NET MAUI, so you can consider it just like a button or an image. You can put it wherever you like. You can make it as big or small as you like. It doesn't have to consume the whole page. And it provides all of the interaction events that come with .NET MAUI graphics. So you can handle all of your touch input directly in your scene, in your application, and modify around. The other thing that you might note is that because in the Orbit game, the background is static. So actually there's no point in rendering that every time we go through the render loop. So that sometimes the optimization is to just stick an image in because it never changes. So actually, there's little kind of tweaks like that you can do to save on some effort. And of course, you can stick buttons on top. Again, it's all Z index based, so you can actually control what goes on top. If you want a pause dialog or a game over message, then you can put all of that into your UI. And then the only other point that has been under discussion, and it's not clear whether it's a good option or not, is whether we completely remove the need of a content page and actually have a game scene page, and therefore it will just be a full screen scene to view. Once we've initialized it and we've put our surface on the screen, we then need something to render. So we call this a scene, and typically a scene is any screen in your game. So and its associated state. So what you'll see is, in this scenario, it's the home scene, so it's when you first start the application. It's relatively simple, actually. You don't need the bottom two methods. They're just there to obviously highlight what you can do. So you can update state in the scene if you really wanted to, and you can render things. So in some games, there might be a dynamic background that you want to change. Therefore, you could do that in the scene. And then simply, the scene contains the objects that live in the life of the game. And you can see here we're just adding a ship, a sun, and a planet. And they all come through the magical dependency injection that we'll get to see shortly. Once you've added you've got your surface to draw on and you've got your scene, you then need to glue the two together. So you can actually just call, there's an implementation called the Game Scene Manager that controls the state of the scene and ultimately the game. We have the load scene method, which has recently gone under a bit of rework in the fact that we can scope instances there now. So if you've got an instance of a game object that you want to share across the life of a scene, that's all taken care of for you. And actually, we will cover a decent example of that. And then every time a load scene closes, then you can tidy up after yourselves. So you don't have to have singleton instances lying around, which will continue to consume some level of memory. You get all of the lifecycle events, so you can stop the game. You can subscribe to them as well. So if you want to show and hide, you want to show a pause menu when the game is paused, but you're not calling pause, then you can interact with all of that. And the loop stops as well whenever you pause. The loop is only running when you've started, so you don't have to worry about other objects being updated in that regard. So our final item is the game object itself, and these are kind of the main building blocks of a game. I've got written down here, game object represents a single object in your game, which is possibly not the most helpful description. It can be whatever you like. It can be a character, it can be a component of the character, it can be an enemy, an asteroid. as you can see in this example. Ideally, if we try and apply some level of solid principles, then we'll try and keep things as simple as possible, but like I say, it can be literally whatever you like. You can see that we've got the ability to load an image. That's all built in, so you can do that, and then at the bottom we then have the ability to draw that on the canvas. You can tell it where to draw it, and how big to draw it, and we'll get into some more detail as to actually what .NET MAUI offers in terms of the canvas interaction shortly. Which is now. So let's take a quick look at the concepts that can be used in a real application. Which is here. Please do let me know if the code wants to be a little bit bigger. It's massive on my screen. Oh, what's it doing? It's opening in a new window. So as we can see, we've got the user orbit engine extension method that we're calling, and then as we look further down, then we're just building up some of the dependencies that we're going to want to use. So our main page has dependencies on things in the game, so we have to register that. Then we're making use of some of the essentials APIs with the haptic feedback and the vibration and the file system. Then there's, for the audio playback, there's a third-party package that we have to use, and then some of the internals, and actually to try and simplify the size of this method, there are little extension methods to then actually expose the bits that you care about just under each of the folders. This is in terms of a game implementation rather than the engine itself, but it typically works quite well. And you may notice here is what I was referring to with the scoped instance, in the fact that every time you call a load, you'll have one battery instance that can be accessed by everyone. And therefore, well, if we look here, so actually we've got a ship that owns the battery. We've then got a thruster that can consume power from the battery, and then we've got a battery level indicator that actually presents it on screen. In that way, that means we can share the instance across the life of the scene, and we don't have to worry about singletons or having to pass things around. We can still utilize the dependency injection that comes with .NET MAUI. So we've done the registration, we've added it to here. So if we then look at in the code sample, in the slide on the code sample on the slide, sorry, we had a fairly simple UI. Obviously, I couldn't have fit all of this on the slide. It would have been really quite difficult to read, but you can then start to see that you can construct your UI however you see fit. There's the game scene, and then we've got things overlaying on top of the scene based on the button panel that you can speed up and slow down. Things like being able to start the game, pause the game, and then there's even the pause menu that pops up, all controlled via the state of the game. And if we look at how we then add it in, so we've got this load scene method again here, which loads that in for us, and then we can respond to states in the game. So you see, like, we know once it's loaded, then we'll start playing the background music. Once it's started, then we will hide the title and the play button, and then we've got as much power as we like to do there. So you can do animations, you can do whatever you like with, because it's all UI based. And as I mentioned, we've got the ability to use all of the .NET methods, so that there is quite a level of different interaction events that you can subscribe to. They have better desktop support now, so you can deal with hovering. Obviously, it can't tell that your finger's hovering over a touchscreen, but you can tell that the mouse is hovering over a button. So you can build in better support for desktops if you're aiming at building for that. Then, once we've called load on our home scene, we can then look at the scene is really quite simple. I know in the slide we actually had more code because it was just proving that you've got the methods that you can interact with, but in theory, at least in the majority of the scenarios that I've come across, is that the scene doesn't do too much. It's just a container for the objects themselves, but it is the thing that holds the state, and it's called to deal with the rendering and the loop updates. If we then start to just look at a slightly more complex example in terms of the canvas interaction. So In the ship, we've got the complexity that it's rotating around a planet, so we need to make sure that it is in the right place. Thankfully, with the beauty of the .NET MAUI canvas is the fact that we can move ourselves around, we can reposition our origin, so actually the translate will say, well, the center is now actually, 0, 0 is now actually in the center of the screen rather than top left. Then we can rotate the canvas, and then actually we just have to draw the image where we expect it to be. And that then actually drastically simplifies the maths that we need to do in order to put something on the screen. And then you don't have to worry about tidying up the translation or the rotation or any of that state. Once you leave the render method, that's tidied up for you. So actually, you can mess around to your heart's content, get yourself in a certain position, and then you won't be affecting any other objects. That's all done for you. Okay. That's fine, okay. So we've covered a little bit about how we can build the game. Then there are some tips and tricks that I like to kind of expose because, like I say, these are pitfalls that I've fallen into that have really quite complicated matters. So I'd like to come across a brief example. So if we imagine we're controlling a ship that's flying through space, they say that suddenly some asteroids are going to appear, and then we need to consider how to handle that collision if they do hit our ship. Obviously, we don't want that to happen, so if we give ourselves some guns on the ship, we've got a way to defend ourselves. But if we say they're not just going to be any guns, they're going to be smart guns, so actually when the asteroids come into range, then they're going to fire, and then what it's ultimately going to do is it's going to leave us with a resource that we can collect, which will be the next animation, and therefore you can start to see how complex this can become really quite quickly, because if you've got a few things doing all of this, then there's a lot of stated information in a single object. But we can actually split it down into something that becomes much more simple. So what we can say is we can have a hull that can collide with an asteroid. Then we can say that we've got a gun that will fire when something comes into range. One detail that's not on this slide is actually the pulse colliding with the asteroid. I got so deep in the animations that I don't dare go any further. And then you've got the resource that can collect when it comes into the range of the sensor. And then actually you've got quite individual little things that do a single task, and they drastically simplify the implementation and hopefully make it easier to maintain. To continue on with some more tips and tricks, the statement update really should be display independent. So this comes into considering what devices you're running on, or trying to not consider what devices you're running on, if that makes sense. If you imagine you've got a character in the screen, say you're running on a 1920 by 1080 screen, and the character is in the middle. If you then want to represent them on a different screen, if you're playing a multiplayer game, the screen size is changed, or you've on a mobile device and it rotates, you're going to run into all manner of trouble if you're storing 960 by 540, which is the middle, because that's no longer the middle. So if you can store your details in terms of something that's relative to the size rather than the size itself, so if we say we saw 0.5 by 0.5, you can then translate that in your render. So as long as you can separate out update to render, then you're going to run into far fewer problems, like ships jumping around on a game when it's not supposed to. I don't know about yourselves, but when I play mobile games, I really lack the positive feedback that you get from physical buttons. Not actually knowing that you're tapping it, you get frustrated that you've missed it. Obviously, you can't provide that physical element, but you can actually provide some level of positive feedback that they've actually done something. So you can put some haptic support in to actually let them know they have clicked on the button. And then you can also look at maybe adding audio, so you can add sounds, so click sounds or things like that in terms of you let them know that the button has been clicked. Now, I will be honest, I'm quite a silent gamer. My phone's always on silent, so actually I don't necessarily get the sound effects, but the haptic support really does make a difference. But it does show that there's a wide range of different possibilities to be able to provide positive feedback to people. There's not a one-size-fits-all for all of this. And then with sound effects, not sound effects, but audio in general, you can provide backing tracks for your game as well, and that will then enable to provide a whole different element to the game. It really does make a difference. And on that note, we do actually have sound in here as well. So actually, I don't want to leave this playing in the background while we're talking. I've changed the control screen. So you can then actually add little elements that actually make it feel much more alive. You're actually letting the user know that they are doing something. And I'll mute that now so we don't go too far. And the only other final point is there is a lot of functionality that comes with the tooling and the framework. So like I keep mentioning dependency injection, but there are a lot of things that are designed to make our lives easier. And because they come with .NET MAUI, then we really want to make sure that we make full use of them. This feels like it shouldn't really be a tip and trick, but it is a really important topic that I always like to try and address and highlight. Accessibility, it really is such an important topic, and I think the sheer fact that the keynote yesterday was heavily focused on it just shows how important it is. .NET MAUI does provide us with quite a few tools that make it easier for us to build a more inclusive application. And if you think that as a really quite crude benefit of making your application more inclusive is you're opening yourselves up to a wider range of people to install it. So if you're charging money, then actually that gives you the benefit that you might actually make more money because you are appealing to more people. What it does do is it gives another abstraction. It gives the ability to interact with the screen reader. So any of the voiceover assistants that come with, let's say, Siri or TalkBack, is it, with Google? It all comes out of the box for you. So you can, if you imagine that you've got a user that's got lost in the game, they haven't actually provided any input, you can actually then guide them to actually realize that they haven't done anything, and maybe you just need to prompt them into what they need to do. The other thing to consider is when we're building our applications, if we're building something that needs to be tapped or clicked, then it's most likely that really should be a button, because that is what buttons do. And the benefit of what .NET MAUI offers is the fact that it doesn't render the button for you, it delegates down to the platform-specific layer, which is a UI button on iOS. And Apple have built in all of their accessibility support around a UI button, because they know what a UI button is, they know what it does, and therefore the voiceover assistant will be able to present that much more clearly to a user. There will always be scenarios, and I think in the Orbit game you'll see that the pause button and the play button are not buttons, they're images. And by default, images are just a static piece of something visual that you can look at. It's not something designed to be interacted with. And therefore, the screen reader won't report that to the user. It won't tell you that you can interact with it. But you can make use of things like the semantic properties that will then guide the screen reader to report that to the user, so you can interact with this, and this is what it does. And therefore, ultimately, that find its way down to the user as well, because you're guiding the screen reader. Actually, what a really quite, I wouldn't say fun experience is to turn your screen reader on and then actually go into a game or an app that you've got and actually realize how much of a painful experience that becomes. But this is actually only really scratching the surface of making games and applications more accessible. The section at the end, there are quite a few slides and resources in order to help you on that journey. You can start to think about, there's other examples where if you want to consider visual impairment, then actually there's levels of contrast ratios to make sure that your content is actually presentable to the reader. So you want to make sure the difference between the background and the text there's enough of a contrast to make it legible. And also certain fonts and things like that actually benefit you. And then there's other things that you possibly could consider is that while in games it's great to be able to animate things, make things move around and flash, actually there are even settings in iOS like reduce motion, and if that's enabled, then actually we probably shouldn't do any of that, because that's actually a bad experience for someone rather than a good experience. And then I should add that the sample games, so in the Orbit repository at the moment, there are 3 sample games to show you how to kind of build things. There's a drawing game, an air hockey game, which is mostly just a proof of concept that doesn't do too much other than looking like an air hockey table. And then there's this Orbit engine. They have some level of accessibility support in, but we're surely trying to build that up to provide a solid set of examples in order to build something that is inclusive. I've tried to talk around what the engine does offer in order to make people want to come and use it and contribute to it. But in short, I wanted to cover what it doesn't offer, which is these are mostly deliberate decisions in the fact that you don't need us to provide you database access. You're running under .NET, so therefore you can utilize whatever you like. You could use Entity Framework, SQLite-NET, or LightDB, or many other services, even cloud-based databases. You could utilize the APIs from Essentials, which we've done with the haptic feedback or the vibration support. There's many others. You can utilize accelerometer, so you can actually introduce that for your controller support, as well as many other things. And the Essentials APIs, I do refer to them as Essentials because they were that in Xamarin, but they've been baked into .NET MAUI now, so they are just part of the ecosystem. But most people just refer to them as Essentials still. We can provide multiplayer support via services like SignalR or web services. And because both client and server will be running .NET code, you can actually share the code between the code bases. And in fact, I took part in a talk last year where between myself in the UK and James in the US, we live streamed the drawing sample game from this repository. And it mostly just worked with relatively limited amounts of code. SignalR is actually really quite an impressive technology when you look at what it's doing under the hood. And then there is the part that I really like, and that's having the ability to interact with the platform-specific APIs. So I did mention this briefly before, but if you've got, so like I said, you wanted to implement a particle system in your game or your application, you don't have to wait, you don't have to be held up by .NET MAUI. You can actually just write the functionality yourself, because you can interact with .NET for iOS, .NET for Android, and they are bindings wrapped around the entire iOS or Android libraries. So you've got the full power there. So you don't have to be held up. And then finally, we mentioned audio support, or actually the benefits that come with audio. Now, audio playback doesn't come with .NET MAUI. It also doesn't come with the engine. But there is a third-party package that will enable you to do that. So there are options out there. It just doesn't necessarily come out of the box with what you've got here. Testing is a tricky subject. So .NET MAUI themselves, they are investigating, the team are investigating how to do UI testing. But as I say, it's under investigation. So in terms of I wanted to find a way to enable people that are building a game to be able to test their creations relatively straightforwardly. So I've tried to take the approach of snapshot testing to some extent. It's not a new concept, and if anyone's not familiar with snapshot testing, the premise is that you write a test, you accept the output that comes out of it, and you consider that what's called a golden master. And then any subsequent test run, the new output is then compared against the golden master output, and if there's any difference, you'll get a failure. And there can be many different types of output for a test. This one obviously renders an image, but you could serialize the state out to a JSON or XML, whatever you like, and therefore you've got something that might be slightly more readable in terms of when you want to compare things. Certainly, diff tools will work better with diffing text rather than an image. This approach it's quite a crude example. I mean, it's not rendering the game, but it's aimed at rendering something. And therefore, you can then actually prove what's done. It's creating a scene and then just rendering a rectangle. And what you'll also see, I mentioned before, is that because Skier is not built into .NET MAUI graphics, but in this scenario, we're actually relying on Skier because it's not. There's no platform for .NET 7 support for the graphics, so we have to do that ourselves. So you can swap in the canvas for a skier canvas, and then you can just render it and it'll work. For any eagle-eyed people in the audience, you may have noticed that this test will fail in the next run because there's no red circle that's being drawn in the test, in the subject under test. I'd like to suggest that was deliberate, but I'm not sure I can. But yeah, so I mean, like you say, you can see that it has potential, and I think in terms of being able to do the UI testing this way, it works well for things that have games that provide repetitive behavior. So if you want to test something like a tutorial screen that you guarantee that people always have the exact same experience, then something like this would work. If you're going to introduce randomness into the game, which actually a lot of games do, then you're going to run into problems because things are not always going to be in the same place. If you look at the asteroids, they never spawn in the same place. So typically when we look at that, then we'd end up serializing out to JSON, and then we can use a technique which is known as scrubbing. So you remove the bits of detail that are random, and therefore you exclude those from the test. But if you want to verify that a certain number of asteroids spawn in the first 10 seconds of the game, then you can still verify that, but you're just removing the bits that would actually cause the test failure. The first stop on this journey, I guess, is to aim to try and get something that's reusable for everyone in terms of a NuGet package that could be added to a project and you could build a game. In terms of getting there, there's only 5 items on the list, so it can't take too long, can it? The first one, and I don't know about you, I really struggle with naming things. Child 1 and Child 2 will vouch for that. But someone has suggested the name of Mage, which is Multi-Platform App Game Engine, which sounds quite nice. I can imagine quite a fancy logo for that. And it fits in with the technology that's being used. So that's something to consider. There's the investigation of building in more physics. So obviously the Orbit engine deals with physics. The Orbit game deals with physical elements, but not all games do. So like I said, there's a drawing game example that requires no physics. So we're looking at potentially building a separate package for that will provide helpers in order to simplify anything that you think you need to build. In terms of diagnostics, you saw we had the bounding boxes on the screen, and the hope is that we can try to make it as easy as possible, because I've been there through the frustrations of why is this not here, it's over there. Well, actually, quite often you don't even know where it is because it's out of bounds. So trying to build in levels of diagnostics there to simplify that. I think we've all been through the frustrations of trying to diagnose something that's challenging. And then things like being able to display the frame rate on screen, things like that, just to simplify a developer's job. We want to add in a bit of better lifecycle support. So objects don't know when they're added or when they're created or destroyed, so actually you can't tidy up resources particularly efficiently at the moment. But that's, I'm not going to say it, it's coming soon. Hopefully it would, I was going to say it's going to be trivial, but that's a terrible idea. And then we want to further enhance the testing support. So we've got things like the snapshot testing, trying to investigate whether there's other options in order to make it far simpler, because I know when working on side projects, testing tends to kind of fall by the wayside rather than actually being a high priority. But if we can build it in and it becomes really quite easy, then there's no excuse, is there? And finally, I've been told I have to present this. When I first told my daughters that I was building games and going to give a talk, they became so excited they went off and designed their own game and actually wrote their own PowerPoint presentation that they thought I was going to present. So if anyone here is interested in a Hello Neighbor cross with gummy bears, then that might be coming fairly soon. And then actually, just before we do wrap up, so it looks like we would have time for questions, there are some really great resources that I've come across on my journey. See a smile there. So Audio Jungle provides really great audio, as it suggests, sound effects and music. They are typically paid for, but they're not expensive, and like I said, they do really make a difference. The only thing that I discovered is that when they give you samples as well, so you can download it and play it. They just put, I never know what the correct term is. It's not a watermark, but there's a voice over it to make sure that when you're distributing it, it's not paid for. You can become quite used to that. So actually when you pay for it and you remove the person speaking over it, it actually feels unfamiliar and quite strange. Open Game Art is a really fantastic resource. It's a portal for artists that share their work. It's typically open source, so depending on the license that's up there, you can use most of it for free, obviously with the levels of attribution. And that covers music, sound effects, graphics, a multitude of different graphics options. And the Orbit engine uses all of that. All of the graphical or artistry comes from there. So that's the sound effects, the music, and the imagery. And then there's two other great repositories which helped inspire this. There's a certain trains.net by this man down here, David. And then there's a Flappy Bird clone that was built on top of Skier Sharp by Matthew Leibowitz, who maintains Skier Sharp. And then that's it from me. I want to thank you very much for coming and being a great audience to my very first ever conference talk. I hope it's been as much fun listening as it has been talking about it. The point I'd like to leave on is I've spoken about a journey, I've spoken about this engine that I think can potentially solve problems. I'm not going to say it will solve all problems. There are, like I showed you in the earlier slides, you can achieve these problems via typical means. So if you want to use like MVVM to build an app, and there are better applications that are suited for it, so like a card game or things like that, you could use what you're more familiar with. You don't have to go and learn a new piece of technology. And that's kind of where I started this journey, thinking I didn't need to, and then created a different piece of technology, which I guess, as I say, is part of the fun, part of the journey. But I would love to see whatever creations people come up with, and please do reach out and suggest any suggestions or whatever there is. So thank you. Would anyone have any questions? Or? Well, no, sorry, it's all rendered natively on each platform. So actually, .NET MAUI is taking care of all of that. So you can render on WinUI through their drawing layer. If they've got their own implementation on WinUI. When we tested it, we need to fire up emulators. There's multiple ways of looking at this. So you can run unit tests, and you can force it. So in the code example here, if I jump back, in this you can actually run this just generally on your machine. You can just run .NET test, and it'll execute that for you. There is another piece of technology with .NET MAUI called device test runners, which allows you to run it up on an emulator. So you can spawn these tests up onto an emulator. It's not the most pretty. It kind of looks like Test Explorer on the device, and then you can run all of the tests there, but it's running it in that environment and not just on .NET 7. It's running on .NET 7 for Android. So you do have that power to do that.
The slide you have there, there doesn't appear to be any assertions in the tests. Is that provided by the test attribute?
No, there should, in theory, be a verify method at the end that would actually call that. So typically with snapshot testing, you don't tend to write assertions. You end up just verifying the state of an object. So what really should have happened is rather than writing the bottom two lines would be replaced with a verify the scenery. So you verify the state of the scenery, and then each time, so this implementation here, that would be inside of the verify method, and it would compare its output to a known output. Okay. Two faults on this slide. Okay, if there's no further questions, just want to say thank you all again.